Good evening. My name is Mohammed Al Rassan, and I'm a data scientist for the MSDS Consulting Group. And tonight we're going to explore the ABV and IBU exploration of beers. As you know, the beer industry is a highly competitive and evolving market with a wide range of factors that impact the company's success. At MSDS Consulting Group, we specialize in leveraging data science to assist companies in quantitative decisions, drive innovations, and stay ahead of their respective industries. Tonight, I'd like to share insights we've gathered from a year's worth of data analysis in the beer industry. First, we observe how many breweries are present in each state. In the past year, there is a mean of 11 breweries in each state. Here we can see the states with the most and least amount of breweries where Budweiser market segments should be focused. We can see Colorado has the highest number of breweries with 47, followed by California with 39. On the other hand, the states with the lowest number of breweries is the DC, North and South Dakota, and West Virginia, each with one brewery. It's interesting to note that many of these states have similar populations and may not have as much demand for beer as the other states, which could explain the lower number of breweries. Overall, this plot can provide a valuable insight into the competitive landscape for the beer industry and can be used to inform decision making around market expansion, distribution, and branding strategies. Overall, this map provides a great overview of distribution of breweries across the United States. It allows us to see patterns and trends in the data which may not be immediately apparent when looking at the raw data alone. This information can be useful for identifying potential opportunities for growth and geographic location. Is the data completely missing at random? We address the missing values in each column found in our data. Specifically, we found that there are some values missing the ABV and IBU columns for quite a few beers across different breweries. So we wanted to see the missing ABV and IBU values to get an idea as to how those data points are spread across beers overall. We could see the missing ABV values spread out over many present ones in the data set. This gives us confidence that suggests that the data is missing completely at random, and so we do not need to include those beers with missing values in our analysis. We plotted the missing IBU values alongside present values, and the scatter plot presents the missing values that are spread out randomly across the data set. This is good news because if the missing values were systematic, it could indicate errors in the data collection process. This random distribution suggests that the missing values is due to chance and not related to any specific characteristics of the different beers and style, location, state location, or the data set. Overall, this insight provides us with confidence that the records aren't missing due to any specific biases or systematic errors. Moving on, we computed the median alcohol by volume, or ABV, which is a standard used to indicate the alcohol percentage in beverages, and in the International Bitterness Units, which measure the bitterness of the beer, which is primarily determined by a number of hops used during the brewing process. The IBUs are used to provide a standardized scale for measuring bitterness from 0, which is no bitter, and over 100, which is extremely bitter. We can observe that DC and Kentucky have the highest median ABV values of 6.25%, while Utah has the lowest ABV value, median ABV of 4%. In terms of IBU, Maine has the highest median IBU of 61, while Wisconsin has the lowest median IBU of 19. Moreover, we found each state had the beers with the highest ABV and IBU values. So far, ABV and IBU, we can observe the top 5 states respectively. We can see the state of Colorado takes the number 1 spot with the ABV of 12.8%. On the other hand, for the top 5 bitter or IBU beers, we can see the Oregon to be the winner this time with a whopping IBU score of 138. Here we can see the table of summary statistics observe that we have a minimum ABV level of 0% for non-alcoholic beers and a maximum ABV level of 12.8%, a median ABV level of 5.6, and a median ABV and a mean AB level of 5.97%. Here, we can observe the histogram of ABV values. Observe that there is a wide range of values for the ABV variable, with many of the value in the range of 4 to 7%. The distribution appears to be unimodal. Also notice the histogram is roughly symmetric or a little right skewed, except for the long right tail, which indicates that there are some beers with high ABV values that are considered outliers. In the case of the Colorado beer, in general, the ABV variable shows a reasonable range and distribution of values for beer, and most of the beers having a relatively moderate alcohol content. Now, we explore if there is existing an apparent relationship between the bitterness of the beer and the alcoholic content. We can observe this relationship between the ABV and IBUs. The gray dot represents individual beers, and the red dots, and the red line, represents a smooth curve fit for the data. Overall, there appears to be a slight positive relationship associated between ABV and IBU, but we can see a downward trend later since the account for the outlier that has a high ABV and a low IBU. The alcoholic content for beer increases, or so does its bitterness, as indicated by general upward trend for the red curve. However, the relationship is not very strong, as there is quite a bit of variability in IBU values for any ABV value. This suggests that while there is some relationship associated between ABV and IBU, other factors such as the type of beer, brewing methods, and ingredient choices are also important in determining the bitterness of the beer. Furthermore, we wanted to identify whether there is a relationship between beers, ABV, and IBU values, and its classification for IPA and ales. To answer this question, we used a machine learning technique called K-nearest neighbors to classify beers as either IPA or ale based on their ABV and IBU values. To do this, we first ran the analysis multiple times with different training and testing data sets in different values of K, which is the number of the nearest neighbors used in the classification. Here, we happen to see that the best K value is 5, with an accuracy rate around 86%. The confusion matrix here is a 2x2 table that summarizes the performance of classification model by comparing its predictions to the actual labels of the table set. Here, the rows correspond in actual classifications, and the columns correspond with the predicted classifications. We treat ale as being a positive classification, and IPA being a negative classification with 4 possible outcomes: a true positive, a false positive, and a false negative, and a true negative. Here we can observe statistical performance results for the K&N model, apparently classified as beer as an ale or IPA. We can visualize the decision boundary for the K&N model with the straight line that separates the different types of beers based on the ABV and IBU. The K&N model uses the boundaries to classify new beers as either ales or IPAs. We can infer from the heat map that Budweiser could adjust their beer findings to include more IPAs, particularly those with high IBU values, to meet customer demand and capitalize on the popular style. In general, IPAs have higher ABVs and IBUs than ales, but sometimes there is also overlap of these characteristics. Budweiser could design new beers based on these characteristics and classify their beers as IPAs or ales, and market these in states or regions where the demand is high for these styles. I hope this information is useful in your decision-making process. I want to thank you guys for tuning in. My name is Mohammed Al-Rasan. As part of the MSDS consulting group, I provided my email for any questions, and I will provide this PowerPoint slide in the video. Appreciate you guys. Thank you so much, and have a good night.